Hey Pre-Calc, Mr. Rashid here. Today we're looking at finding the 6 trig ratios of a right triangle. So there actually used to be a lot more in terms of trig ratios. These come from primarily the terms and names come from navigation in the 16th and 17th centuries. So to figure out where ships were heading and where your location was compared to some other city, then you'd use these kinds of ratios a lot. And that's where some of the terms originated. And they had a few more too, like coversin and versin and a few others. Now we've come up with this short list of 6, and you might have already looked at the sine, cosine, and tangent and know a lot about those. The cosecant, secant, and cotangent, which is the 3 that we're looking at here, they show up a lot in calculus and also in polar coordinates and a few other things that you'll see in your math classes in the future. So it's good to sort of see these now and know what they are before they show up later. Okay, so the first one here, sine, is something we already have seen. So the sine is the opposite over the hypotenuse, and the cosine is adjacent over hypotenuse if you have a right triangle. So depending on the angle, so if I'm interested, let's say, in this theta here, then my opposite is over here, and then my hypotenuse stays the same. Then adjacent depends on which angle. So this is the angle I'm interested in. That's my adjacent leg then. So that's adjacent over hypotenuse, and then tangent is opposite over adjacent. Then it's just the opposite leg over the adjacent leg. Now the new ones here are cosecant. So that's CSC is how you spell it or write it there, CSC, and that's hypotenuse over opposite. And what you'll notice is that it's just a reciprocal of the sine, so it's associated kind of with the sine. We can even write 1 over sine theta is the cosecant. So the other one then is the cosine, and the secant is the reciprocal of the cosine, where it's the hypotenuse over the adjacent, and so you can write almost the same thing. 1 over cosine theta is your secant theta. And you can also just flip your ratio around. If you have your cosine theta, you can flip it around to get the secant theta. So this is secant theta. All right, and then the last new one is cotangent theta. So cotangent theta is associated with your tangent, and that is the reciprocal of your tangent. So 1 over your tangent theta is equal to your cotangent theta. All right, so those are the definitions, and we already talked about this. Secant is the reciprocal of cosine, and cosecant is the reciprocal of sine. Cotangent is the reciprocal of tangent. Okay, so the first kinds of problems we'll see is where we have to find all the 6 trig ratios, and this is more to get practice with finding the ratios rather than solving any particular problem. So, but we will see more complicated examples of how we would have to find all the trig ratios. So this is great practice to have now. And in this case, the triangle has already been given to us. So let me just write them down. So I have sine theta, cosine theta, tangent theta. Now if I have to solve for all 6, I just write all the 6 down. So then I write them in relation to each other. So the reciprocal I know of sine is cosecant, and the reciprocal of cosine I know is secant, and the reciprocal of tangent is cotangent. So I write those next to each other like that. Okay, so we have here that we're given two of the sides already, and those are both legs. I don't have the hypotenuse. The hypotenuse is opposite the 90. And I can always find the hypotenuse because I'll need it eventually to use for many of these ratios. I'll need the hypotenuse. So let's do that here. A squared plus b squared equals c squared, where c is the hypotenuse. So I have 8 squared plus 15 squared, and this is 64 plus 2 to 5, and adding those I get 2, 8, 9. So this is all equal to c squared, and that's c squared. So then taking the square root and the square root, c is equal to 17. So my hypotenuse there is 17. Okay, then, so to work out the sine, in this case, we are given a specific angle, angle B here. So I should actually just write B for all of these. Okay, so the sine of B is going to be the opposite over the hypotenuse. So the opposite is 8 and the hypotenuse is 17. The cosecant is just going to be the reciprocal of that, so that's it. Then cosine is going to be adjacent, so that's adjacent to my angle, over the hypotenuse, that's 15 over 17, and I know that the secant is just a reciprocal of that, so 17 over 15. I just flip those. The tangent then is the opposite over adjacent, so that is 8 over 15, opposite over adjacent. Then the cotangent is the reciprocal of that, which is 15 over 8. And that's it. I'm done with the ratios. So let's take a look at some problems now. So we have the sine theta is equal to 2/3. And in many of these problems, I recommend that you draw your triangle and you label the sides and then calculate what trig ratio you have to find. Now, sometimes you get lucky, and so like in this problem here, cotangent and tangent are just reciprocals of each other. So I'm not going to really draw the triangle and just going to recognize that that's a reciprocal. You could draw the triangle and see exactly what they're talking about there, but 1 over the cotangent is tangent, or 1 over the tangent is the cotangent. So they're just reciprocals. You're flipping around the numbers. So the tangent then in this case is 4/3, and we're done. Okay, so and the same, kind of the same thing here, but they've given this to us as a decimal. So cosine 1 over the cosine of theta is the secant of theta. So here, let's erase. The only thing that you could use a calculator and plug that in and get the inverse, or I know that 0.75 is the same as writing 3 over 4. So cosine of theta is 3 over 4. Then the secant of theta is going to be the reciprocal of that, or 4/3. So I'm done with that. Okay, now let's do the harder ones, which are up there. Now in those cases, we have to draw the triangle here, like this, Let's call this our theta. Then sine of theta is 2/3. That means opposite over hypotenuse is 2/3. And now to find cotangent, cotangent is the reciprocal of tangent, where I would need the the adjacent and the opposite side. So, but this would be adjacent over opposite. Now I don't have adjacent right now, so I'm going to need to use the Pythagorean theorem. So in this case, I have c squared minus a squared equals b squared. And so my hypotenuse is 3 squared minus 2 squared. And so this is 9 minus 4 equals b squared, or 5 equals b squared, taking the square root, end up with b equals square root of 5. So my missing side length on this triangle is square root of 5. And now I can solve the problem. So I need adjacent over opposite. So square root of 5 divided by 2. So that is the cotangent. All right, next one. Now this is very similar in that we're really not given. We need one of the other sides. So here's my right triangle. Here's my theta. And I have that secant is 7/5. So, this is hypotenuse over adjacent. It's a reciprocal of cosine. So cosine is adjacent over hypotenuse. So my hypotenuse is 7, my adjacent is 5. I don't have that missing side, which I really need to find sine, right? That's going to be my opposite that I need to find the sine. So once again, we just do the Pythagorean theorem. 5 squared plus my missing side is equal to 7 squared. So b squared is equal to 49 minus 25, and that is 24. And so if I take, now, if I put b squared here, I take the square root of both sides, I get b is equal to the square root of 24. And if I take out one of my squares, then that is the square root of 4 times the square root of 6, or 2 times the square root of 6. Okay, so now I have that is 2 times the square root of 6. I can write the sine, which is the opposite over the hypotenuse, which is 2 times the square root of 6. 2 times the square root of 6 over 7. Okay, and that's it then for these examples in this video. I'll catch you in the next video. Bye.